Click the bell icon to get latest videos from Ekeeda.
Hello guys, today in this particular video we will learn the bipolar junction transistor and its working. We will focus more on the working as we have learned the construction of bipolar junction transistor in detail in the previous video. As we have learned the construction process of the BJT, we will proceed further for the working directly with keeping in mind that two aspects of the construction process are very important. One is doping concentration and another is area of the BJT. Now, area of the emitter, base and collector region. Emitter is heavily doped and moderate area. Base is having very less area and lightly doped. And collector is having very large area and moderately doped. So this is how the construction, according to the construction of BJT. Now we will start with the working process. Considering the fact that this is NPN transistor, so we'll focus on we'll consider NPN transistors. So as far as NPN transistor is concerned, let us see, we will be having very large number of electrons which are present and working as majority charge carriers for this particular space of BJT. So as these electrons are moving towards the base of the BJT, which is of P region, if we have not yet connected to any external bias potential, then what will happen? Before forming this particular junction, right, these electrons will try to enter in this particular region of base, right? But base is lightly doped. That means, for example, if we take one example that the emitter is having how many number of electrons? Let's say emitter is having 100 number of electrons, right? Base is having 10 number of holes, 100 electrons, and here 10 number of holes, right? Collector is also having, let's say, 50 number of electrons. As this is heavily doped, this is lightly doped, and this is moderately doped, and that's why these figures are coming like this: 100, 10 and 50. Now we will start the operation. Before forming these particular junctions W1 and W2, what will happen? That is nothing but diffusion process. So we will say at the time of diffusion, electrons will try to move towards the base side. So 100 number of electrons, entire electrons, that is majority charge carrier, will try to enter into P region. And what will happen when they enter into P region? They will realize that, oh, here in this base region we have only 10 holes, right? So those electrons having very large amount of energy, only those electrons will occupy that particular space. That means nothing but deficiency of electron called as a hole, right? It's nothing but the empty chair filled by the man called as electron hole recombination, and that process is nothing but your diffusion in this particular case when no external bias potential is applied. When the time of diffusion, only 10 electrons out of 100 electrons in emitter recombine with 10 holes in base region. So what will happen? Electrons in emitter and holes in base will get recombined, but here only 10 number of electrons in emitter and 10 number of holes in base will get recombined. But keep this in mind that all the electrons are trying to move towards the base region. Out of that, even though this resistance, in that process, this particular junction will get formed due to the formation of ion as same as that of the diode working. So as junction get formed, right, these electrons will enter in less than 100 numbers. So let's say that, consider the fact that only 50 number of electrons are reaching in this particular region, right? When 50 number of electrons are reaching in this particular region, then out of that 10 electrons are recombining with the holes out of 10 holes, right? So what happens about 40 number of electrons, right? So these 40 number of electrons will try to move away from this particular negative ions. So as these electrons also moving towards the base side, then what will happen? At the base side, so many number of electrons are present, right? So this is how the EB junction and CB junction get formed and BJT diffusion process gets completed, right? So as these electrons will get sufficient amount of energy to move towards the collector side, they will get the energy to rupture this particular junction and they will move towards the collector side, and that's why we are keeping the collector side area is large to hold all the electrons which are coming from the emitter side. I can keep them at the collector region, and that's why collector region is moderately doped so that only 50 number of electrons are available, but the space which is required for the 100 number of electrons is also available at the collector side, so that all the electrons which are moving from the emitter side towards the collector side also can get occupied in the collector region. So this is how the general working of the BJT. We have learned this particular with figures, and now we will learn the different modes of BJT as far as working is concerned. This is all about the BJT working as far as only diffusion process is concerned. Now we will learn the BJT working in different modes. Now here in this particular process, we will say we have applied the two external potential supply. One is at emitter side, one is at collector side, and base is common for emitter and collector. Yet we have not included the input side of BJT and output side of BJT because we have not yet studied the amplification with BJT. So we are generally discussing the general working of BJT. Let us concentrate on the emitter, base and collector region. Let us see that all the electrons are present over here, and if we are applying particular polarity of VEB and VCB, so that electrostatic force will get developed due to VEB and VCB external supply, and accordingly electron will get aligned towards base region or away from the emitter region. Similarly, collector will get aligned towards the base region or away from the collector region. So we will first learn how many possibilities we will be having for the operation, right? First possibility that we will be getting, these are nothing but the different modes of operation. Let us see. First possibility that we will be getting is VBE. This is EB junction and this is CB junction. So we will more concentrate on EB junction and CB junction. Now tell me that when EB junction will be forward bias, as this is N-type region, we will place positive supply towards the emitter side, then I can say that electrons will come towards positive side. If we apply negative supply towards the emitter side, then only then electron will move towards the base region and recombination will get happen. Now if we are applying the same potential to VCB, then what will happen? these electrons will also enter into the base region, but we don't want that. We want all the electrons which are emitted from the emitter region get collected towards the collector region, in the collector region. So what we will apply? We will apply the fact that we will apply the polarity of the VCB such that electrons will get collected in the positive terminal of battery. So what we will apply? We will say EB junction should be reverse bias and CB junction should be forward bias and CB junction should be reverse bias such that my current will increases linearly. So we will say first operation is called as active region, and that is happened when CB junction is reverse bias and EB junction is forward bias. We will learn these operations separately. Second is saturation region. When I am saying कि CB junction and EB junction both are in forward bias condition. So when CB junction is also forward bias and EB junction is also forward bias, then in that particular case I will be getting the value of the current which is in saturation region. Third is cut-off region. In cut-off region, the cut-off word itself tells you that cut-off means my BJT will not conduct, will be in very high impedance state, very high resistance state such that current will not flow due to majority charge carriers, rather very less amount of current will flow through that is due to minority charge carriers. It's in the range of nanoampere or picoampere. So this cut-off region will obviously lead to conduct very less amount of current. In turn, it will be having very high amount of width of barrier and barrier potential as well. So to increase the length of the barrier, I'll be having EB and CB, both junctions should be reverse bias. So I will write it as CB junction also should be reverse bias and EB junction also should be reverse bias, right? And the fourth region that we generally do not take care of, and that is called as reverse active region. In that case, we'll be having CB junction is forward bias and EB junction is reverse bias. But due to the construction of the BJT will not allow to have the conduction process in this reverse active region. This is because emitter is having very moderate area, collector is having very large area, and the base which is having very less area and the doping concentration as mentioned in the construction of BJT. So these are the modes of the operation that we have discussed. Let us consider very few concept in this working process. One concept that we have to learn, which is very important for Viva perspective as well, that is called as base width modulation. This concept gives you the idea that something is changing with respect to something. So the modulation is nothing but this is general statement of modulation word. Change in something with respect to something or due to something, right? So base width is changing, right? So that's why the word base width modulation. Now if you see the actual base width, is this, right? But my available base width region is only this. So the practical base width region is continuously changing by changing the operation of the EB and CB. If EB and CB both are in forward bias region, then I can say that this particular region of base width will increase. If EB junction is forward bias, CB junction is reverse bias, then base width, actual base width of towards the collector side is reducing and towards the emitter side it is increasing, right? So this is how the change in base width due to the applied potential is called as base width modulation. Now what will be the effect of base width modulation? Let us understand. What will be the effect of base width modulation? Now let us understand this. Let us concentrate on the active region specifically. That's why I have written the polarity as in active region. Consider the fact that all electrons are present in this emitter region, and these electrons will try to repel from this particular external battery that is at the negative terminal, which is connected towards the emitter region. As negative terminal is connected to emitter region, electrons are at negatively charged, so repel each other, and electrons will try to enter in this particular region. And that is why as these electrons are repelled by this negatively charged terminal, and these holes will as well repel by this positively charged particle. So what will happen? These electrons and holes will try to enter towards the N region and P region respectively. This is called as recombination process, due to which I can say this EB junction will be forward bias. So all these electrons will try to enter in the region of base. So similarly, this is same scenario. I can say that holes are coming into the emitter region. This is because the chair of the electrons in the emitter region are now empty, and that are nothing but the deficiency of electron called as a hole, right? So electron will leave holes behind, and the holes will get completed with the electrons. So deficiency will get completed with the electrons, that is called as a diffusion process, or else I can say that that's nothing but your recombination process. Okay, as these electrons are here, right, this width will not change in once it is forward bias. In the case of silicon, I can say this is 0.7 volts. That is nothing but the width, that is nothing but the potential, barrier potential of the EB junction. Now as I am changing this VCB, right, this is constant. Okay, if I try to vary this particular VCB, right, if I vary this VCB, as I know that this VCB is placed such that this is positively charged and this is negatively charged, so holes will try to enter in this particular terminal of battery, and due to this positive terminal of battery, electrons will try to enter towards the positive terminal of battery, electrons from the collector region. So what will happen? The width of this particular region will try to increase. But what is my actual base width, right? My actual base width is this much. This is my actual base width. Okay, this base width will again reduce, right? Before starting of the operation, my base width was this. As soon as I place this VEB and VCB, what will happen? This CB junction width will increase. This EB junction width is constant, right? Once these electrons will enter into P region, get fulfilled, will not get sufficient amount of energy to cross the barrier. After forming this particular barrier, will resist the other electrons to move from N type to P type and holes from P type to N type. So this barrier will fix its potential, that is 0.7 volts, same as that of diode, will not change. But as I am changing the value of this VCB, this width of the CB junction will increase. Due to increase in the VCB, what will happen? Actual base width will reduce. So we can say BW dash, right? So BW is nothing but the base width before, right, and BW dash is base width after. Right? Now as I'm changing this VCB, this width will change, and that's why the name is base width modulation. Now in the next slide, we'll have to understand the fact that how base width modulation will change the value of the current, and it will change the value of the incremental nature and the constant value of the current, which is shown on the characteristics of BJT in the separate video. So far we have discussed about the base width modulation. In the next video we will learn the modes of operation of the BJT: common mode operation, common emitter operation, and common collector operation. Okay, so that is nothing but the second working part of BJT that are included in the characteristics of BJT. Thank you so much for watching this particular video. We will learn more and more BJT conceptually. We will dig out many concepts from BJT and we will learn practically about BJT working characteristics in further videos. Thank you so much.